members, many people are very active with the museum, Wendy among them, and thank you so much for having me here today. But I'm here to talk about Randy. Dr. Randall Irmis is that very rare bird. He was a kid who dreamed about being a paleontologist and who actually became one. He was raised in Chicago. He was determined to follow his passion, and so he chose to leave Chicago and go to Northern Arizona University for his bachelor's degree in geology, which he earned magna cum laude. But also, it was because he wanted to be close to Petrified National Forest, where he worked in the summers. He followed that with his PhD in integrative biology at the University of California, Berkeley. And he was studying the earliest dinosaurs, which date from 200 to 250 million years ago. He whipped through his doctorate in 4.5 years, and we hired him, luckily, in 2008. He now is curator of paleontology at the Natural History Museum of Utah, and he's an assistant professor in the Department of Geology and Geophysics at the University of Utah. And I should note that all of our scientists at the museum actually jointly hold positions in academic departments at the university. This is Randy here. He's done field work all over the world, in Argentina, in Ethiopia, Mexico, and in many states in the western United States. Here he is in New Mexico, and lest you think that dinosaur digs are easy and fun, the sand blows off and you see the whole thing laid out, I will tell you that is in fact not the case. It can be very hot and uncomfortable, but the things you find are just wonderful. Randy actually oversaw the installation of the fossils in the exhibits in the museum's new building, the Rio Tinto Center, which have turned out to be spectacularly popular. Randy and his staff and graduate students manage research collections of more than 30,000 fossil specimens, and he has almost 80 volunteers who work in the preparation lab, which you can see from the past Worlds Gallery. And we are always looking for more volunteers. So if you have some free time, we'd love to talk to you. Occasionally, we rope him into doing non-dinosaur stuff. And so right now, he is our resident fossil expert for our current special exhibition, Extreme Mammals. And I didn't bring enough for everybody, but there's some flyers on your tables about that exhibit, which will be open until July. Today, he's going to be talking to you about the Grand Staircase-Escalante National Monument Research Project and all of the amazing dinosaurs we are continuously discovering there. So please join me in welcoming Dr. Randall Irmis.
Well, thank you, Sarah, for that very kind introduction. And it's a real pleasure to be speaking to you today about all the really amazing discoveries that we're making down in southern Utah. And I want to thank you for the invitation to come and talk to you today. So I'm going to talk a bit about our work in Grand Staircase-Escalante National Monument and end up by talking about this critter here, which was alluded to in our phenomenal poem earlier. But I also want to talk more generally a little bit about the project and what it's like to do field work in that area. This project was featured in the May issue of National Geographic magazine, so if you want to see some spectacular photos of what it's like to work down there and some of the dinosaurs that are involved, pick up a copy or check it out at the local library. And I also just want to emphasize that one of the great things about this project is that it's a very collaborative project in terms of working with both federal and state agencies as well as other institutions of higher learning. So we all are, or most of us have been down to Grand Staircase in that region, and this is what it looks like today. But I'm going to be talking about Grand Staircase 80 million years ago, when it was this lush, swampy river environment, much like the bayous of Louisiana, with giant dinosaur-eating crocodiles and duckbill dinosaurs and all sorts of other creatures living about. A very different world than we see in the high desert today. Just a reminder, here's a map of Grand Staircase. Up in the upper left-hand corner, you can see The state of Utah, Grand Staircase is down in the central southern portion, down here. And the rocks that we are working in are highlighted in green in the central part of the monument. This monument is well over 1 million acres, and it's a vast, really unexplored area for dinosaurs and other fossils, and that's one of the reasons it's so exciting. This is what North America looks like today, but 75 to 80 million years ago, it was a very different place. Not only was it much warmer, there were no polar ice caps, but an ocean, a shallow ocean, split North America in two. And Utah was beachfront property on a sort of island that we call Laramidia. Although it was beachfront property, the mosquitoes probably were pretty bad, so there's trade-offs there. And this ocean waxed and waned over millions of years, and we're really talking about the evolution of animals and of dinosaurs and other animals and plants on this vast landmass we call Laramidia that we see over here. And this is probably what it would have looked like if you were there 75 to 80 million years ago. We often see reconstructions of, many, many different dinosaurs all in view. But the reality is you go out in a forest today and you very rarely see an animal. So you might be lucky to see a Tyrannosaur stalk lurking in the background, but it would have been dense forest with rivers and streams and swamps. And we're trying to not only find what new dinosaurs are there, but we're trying to reconstruct what this environment and ecosystem was like. What can we tell about it based on the plants and other animals that are found? Was it similar to ecosystems today or very different? And before I go any further, I want to emphasize that we really couldn't do any of this without our amazing volunteer group that's at the museum. Like Sarah mentioned, we have almost 80 volunteers just in the paleontology program alone that put in over 15,000 hours each year. And that's both in the lab, the preparation lab, like you see here, where they're removing rock from around the bones so that we can study them, as well as in the digs in the field. We also have a very, very active volunteer group that comes out in the field with us. And they're really the unsung members of our team that make it happen. So they're really key team members of the science and work that we're doing. So really briefly, I wanted to just give a sense of what the things that we're finding down Grand Staircase. And this is by no means an exhaustive list, but give you an idea of what the fossils look like and what sort of animals we're finding there. So we've got all sorts of different crocodile and alligator relatives, including this animal here, Deinosuchus, which got up to 40 feet long and almost certainly ate dinosaurs. You would not want to run into this animal while swimming in a lake or stream, so thankful it's not around today. But this is a relative of a distant relative of living alligators, and was around during this time, 75 to 80 million years ago. We also find many fossils of duck-billed dinosaurs, and instead of showing you bones, in this case, this is three-dimensionally preserved skin impressions. So this is what the skin of a duck-billed dinosaur would have looked like in 3 dimensions with all these little polygonal scales that you see here. And it is incredibly rare to find skin impressions of dinosaurs, but over half of the skeletons of duck-billed dinosaurs that we found down in southern Utah have skin impressions. It's an incredible place for discovery, and there's no other place like it in the world in terms of finding things like these skin impressions. And we have both regular duck-billed dinosaurs as well as crested duck-billed dinosaurs, a number of different species. We also find horned dinosaurs like Kosmoceratops here, which has all sorts of various protrusions and spikes coming off of its head. That on the left is the original skull. It's not reconstructed. That's how we found it, except encased in rock. And one of our volunteers put in over 1,000 hours extracting that from the rock in the lab. And it's a really phenomenal specimen that you can come see at the Natural History Museum of Utah if you come visit. We have a reconstruction of what it might have looked like on the right there. We also find tyrannosaurs, cousins of Tyrannosaurus rex. So I'll be talking about a new species in just a bit, but another new species that we found a few years ago is this one called Torontonians. And we have spectacular specimens, multiple skeletons of this animal, at different ages, so we can actually tell how it grew up, how fast it grew, things like that. Again, this is a species that's found nowhere else on Earth. only place it's found is in southern Utah, and the only fossils of it are in museums here in Utah. So this is almost every dinosaur species we find in Grand Staircase is unique to Utah and has never been found anywhere else. So to give you a brief sense of what it's like, we have a number of challenges when we work down there. One of the reasons many dinosaurs were not found before the museum started working there is this is such a remote place, one of the last places in the lower 48 states to ever be mapped. And you have to deal with challenges like the road you're supposed to go on has been washed out by a recent storm, by this wash year that normally is dry most of the year. Things like giant chasms in the middle of the road that no one is going to fill for weeks, so we basically become our own road crew and have to spend hours filling in these chasms so that we can get to where we need to go. So it makes it kind of adventurous, but it's a lot of fun, and you've got good stories to tell afterwards. And because this area is so remote and very difficult to access, there's very few roads, and there's a lot of relief, lots of hills and ridges and things. We often have to use helicopter support to get into where we're going. So some places we can camp and then hike in, but other places are so far away from the road that to effectively do work, we drop in all our camping supplies, we work there for 1 or 2 weeks, and hopefully get helicoptered out along with all the fossils that we found. And so here we are netting up all our supplies in preparation for it to be airlifted in by helicopter using long lines like you see here. And this is how we get everything in and out, all our water, our food. And we're there for a week or 2 weeks, and no one else, you don't see anyone else during that time. But it's amazing because you're in the middle of the wilderness, digging up dinosaurs that no one has ever seen before. And it is really a truly striking place to work. This is just an example of the types of areas that we are searching for dinosaur fossils, walking along valleys and ridge lines, looking for little pieces of bone that are eroding out. And if we're lucky, we follow those pieces up to where they're coming out of the rock, and we dig in and we find more of the skeleton. This is what a dinosaur fossil might look like if you find it on the surface. Is a series of the backbone, vertebrae of the backbone here, eroding out of the hill. And sometimes we dig in and there's nothing more there, and sometimes we're really lucky we dig in and there are most of the skeletons there. So it's really all about hiking around, searching, and looking for these small bits of bone that hopefully turn into something larger when we dig in. And a lot of times so rocks, these sediments that preserve these dinosaur fossils are deposited in horizontal layers. So that means the bones are also in a horizontal layer. So we have to dig in to find where those bones are going into the hill, which means removing all the rock that's above it. And because we're working in protected area, that we can only use hand tools and sometimes gas-powered jackhammers. And so this is all handwork to remove the rock from above the bone layer. So these white things down here are casts protecting the bone layer, and we've got to remove everything above it that you see there by hand to get down to the bone layer. So it's a lot of manual labor, but when you're the first person to ever see a 75 million year old dinosaur fossil, it's worth it. And really gives you a sense of sort of the hard work that goes into finding these things like Sarah was discussing. Actually, that photo Sarah showed was the cushiest place I do field work. So there we've got a campground with ice machines and stuff. But, we don't have that out in the monument. And then finally we get down to the bone layer, and we're able to use smaller tools to remove rock from around the bone. So here's one of our museum colleagues that's just excavated the lower leg bone here of a duckbill dinosaur. That's this brown thing you see right here. That lower leg bone belongs to an animal that was probably 35 to 40 feet long in life. Really giant animals living during this time. And we actually try and leave as much rock around the bones as possible because it helps support the fossil. Even though these are rock, basically, they're still very fragile. And so as we leave as much rock around it until we get it back to the lab, we're in a controlled environment, we can remove that stuff. And we coat it in burlap dipped in plaster, which solidifies kind of like a cast on a broken arm. and keeps everything together, keeps it from moving until we can get it out of the field and back to the lab at the museum, where we can do all the detailed fine work and glue things back together. And then we roll it into a helicopter net and wait for the helicopter to come get us. And the great thing is it means we don't have to carry these giant blocks. Some of the smaller blocks, up to about 250 pounds, will actually pack out on a wilderness first aid backboard, but anything larger than that, if it's not close to the road, we have to helicopter it out. This block you see here was 2,200 pounds, and the helicopter actually had to fly around to do other jobs and get rid of some fuel before it could lift it. It's one of the largest things we've ever lifted out. Hopefully we don't have many more of this size, but gives you a sense of the size of the material that we have to take out. But the great thing is the helicopter can drop it right down into the back of your pickup truck. So there are benefits to using the helicopter. And then we drive it back to the museum where we prepare it in the lab, or I should say our volunteers do the preparation in the lab. So I want to sort of the final third of the talk, give a sense of one of these many new discoveries. We've discovered well over a dozen new species of dinosaurs from Grand Staircase-Escalante National Monument. And this is just one of them, but gives you a sense of the process and also why it's exciting. It's not just about finding new species, but it's also what those new species tell us about these ancient ecosystems. This animal was discovered in rocks that are about 80 million years old, and this is the actual dig site here. Give you a sense of what it's like. And here we didn't have to remove too much rock from above the bone layer, thankfully, and it's pretty soft rock, so that was good. And the bones were scattered and spread out, so they weren't in like position. So we have to remove enough rock that we have a pretty good sense that we've excavated all the skeleton that was there. This was probably a pond or marsh about 80 million years ago, and so the bones got scattered, perhaps by scavengers and water action, and so we didn't find all of the skeleton. But thankfully, we found enough of the skeleton to tell what kind of animal it was, and that it was a new species. And this is the bones in tan that you see here are the bones that we found. And at first glance, you might say, well, gosh, that's like 10% of the skeleton. How do you even know it's a new species? And you're right. The good thing is we found most of the skull bones. And in dinosaurs, skulls have a lot of information, and they differ from species to species. So we were able to tell from the skull bones that this was something new that hadn't ever been found before. This is a reconstruction of the skull with some of the original materials placed into it, so you can see where they go in light position, the upper jaw here, some of the bones up top. You can come and see this at the Natural History Museum of Utah right now, if you haven't already. And we call this new species Lythronax argestes, which means gore king from the southwest. We wanted to, since it was a relative of Tyrannosaurus rex, which means tyrant lizard king, we wanted to evoke a similar name, but honor where it came from. And one of the really interesting things is that this is the oldest large tyrannosaur ever found at 80 million years old. But it's incredibly similar in its shape and of its skull to Tyrannosaurus rex, and it turns out that it's very, very closely related to Tyrannosaurus rex, which is 15 million years younger in time. And we weren't expecting that. We thought it might be more closely related to animals that are found in 80 to 75 million year time range. So it was a really unexpected discovery in terms of who it's related to. And this is a reconstruction of what its skeleton might have looked like, and perhaps the body in life. Color is the artist's prerogative here, but it gives you a sense of very much like Tyrannosaurus rex, just a little bit smaller, but otherwise has the dinky arms with two fingers on it and whatnot, and would have acted and acted very much in life like Tyrannosaurus rex as a big, large predator that basically ate anything it could fit in its mouth. And you might remember that this animal, that during this time between 80 and 75 million years ago, Utah was on a seacoast. So when we reconstructed it, we wanted to show it living on that seacoast with mountains in the background, and may have been scavenging on a sandbar or whatnot. This very much could have been what it was like during that time. The other reason is that when we looked at the evolutionary relationships, the family tree of this animal, it turns out that there was a story to tell about sea level as well, changing through time. And remember, we have, not only do we have this ocean splitting North America in two here, but that ocean, sometimes ocean levels were higher, sometimes they were lower. They went up and down through time. And when the ocean levels were high, that sort of isolated little bits of land up against the mountains. And we think that dinosaurs may have evolved individually in those different places. And that's one of the reasons why we find all these different species in Utah that aren't found anywhere else. They're not, even though we have similar age rocks from Canada and Wyoming and Montana, we find different species. And this is a really complicated diagram, but I'm going to walk you through it really quickly. At the top, we have a family tree, so the evolutionary relationships of dinosaurs. And it's scaled to time, so further back in time is to the left, and forward in time is to the right. And we have Lythronax here at about 80 million years ago, and you can see it's closely related to Tyrannosaurus rex at 65 million years ago. And it turns out that when Lythronax was alive, and the time just before it, is when all these different tyrannosaurs were diversifying. And that's a time of very high sea level. So these various graphs here are showing sea level, and you can see it's at its highest at the time just before Lythronax lived. And so we think we have evidence here that when sea level was high, you got isolation of these different species of tyrannosaurs, and they evolved separately. And that's what we're seeing later on in the record. So not only did we find a new species of tyrannosaur, but it's actually telling us how these groups evolved, these dinosaurs evolved, and that they were affected by things like sea level and climate over 75 million years ago, in this sort of interval of very high sea levels. And the final part, of course, it's all well and good to figure these sorts of interesting research questions out, but part of the reason why I love being a museum curator is the ability to share those stories with so many different people. And so not only do we publish the results in an academic journal, but we also do press releases and exhibits and things to share that with as many different types of people, these exciting stories about the unique dinosaurs that we're finding in Utah and what they can tell us about our world. And here's the press release event we had unveiling the exhibit, which you can go see in the Past Worlds Gallery at the Natural History Museum of Utah. And I just want to end by thanking all of our volunteers that are just the best part of our team at the museum for all the hard work. They prepared most of the fossils of this animal as well as many, many, many others, and helped us on the digs as well, and just key part of every element of what we do. Of course, our funding from National Geographic and the Bureau of Land Management, and all the lands we're working on are national monument lands. So it's been a really great partnership there as well. And I'd like to thank everybody for listening and take questions if there's time.
Can you tell us where you're heading with this project in the staircase? What do you expect to find, or what are you hoping to find? How's this thing going to play out over the next few years?
So the question is, where are we heading? Where are we going? What's left to do? And what do we hope to find out? We've done a lot of work in these rocks that are between 75 and 80 million years old, but that time of highest sea level is just before then, between 80 to 90 million years old. And there are rocks that have dinosaurs in them of that age down in the monument as well. So we're hoping to go further back in time to test our ideas. So these are not necessarily set in stone. These are just based on available evidence. So the way to test that is to go and look for even older dinosaurs and see if they fit into this scenario or tell us something different.
Randy?
Question back there first. Yeah.
So you showed some that were related to the Tyrannosaurus, yet you said that these were different species.
That's right.
So how do you differentiate that?
So we can't get DNA from these fossils. They're way too old. So what we're looking at is various features of the bones. Is there a bump or a knob or a groove on this bone versus on the bone of different species? And thankfully, there are some features we can tell are sort of regular features, but we can tell if something was diseased or not. So people often ask, well, how do you know if that was just a weird bump that one diseased animal had? Thankfully, they look a bit different. And we're looking at the overall evidence. And of course, the more specimens we find, the better to test those ideas. Right now, we only have one specimen skeleton of Lythronax, but hopefully we'll find more that will help confirm or possibly change our ideas about whether it's a new species. But we're pretty confident because no other Tyrannosaur has been found in 80 million year old rocks. It's the oldest one ever found. Yeah. Frank?
Randy, you talked a little bit about evolution during the supremacy of the dinosaur.
Yeah.
And what are your thoughts about the the junction between the Cretaceous and the Tertiary 65 million years ago? What the heck happened there? I mean,
Great question.
was it the asteroid that hit Mexico, or was it a matter of certain evolutionary trends that caused them to be unable to survive? And what's your thinking about that?
The answer is yes. No. So the question was, what happened at the end of the age of dinosaurs at the end of the Cretaceous 65 million years ago? I think it's very clear that a giant asteroid did hit the Yucatan Peninsula at that time and had very adverse effects. But it may not be the whole story. So I think if you're looking for sort of the clearest cause, it definitely was the asteroid causing this big extinction event. But we also know that in India, there were these massive volcanic eruptions called the Deccan Traps that are the reason. If you go to India, there's these huge plateaus in central India. And those are those lava flows. And those started a couple million years before the extinction event. And so it may be that sort of the environment and these organisms were already stressed by the changes from these massive volcanic eruptions, putting lots of greenhouse gases in the atmosphere. And then you sort of had the coup de grace from the asteroid hitting. But it certainly was a major mass extinction and really reorganized both what the organisms that we see on land and in the ocean, and set the stage for the rise of mammals. We have time for one more question, if there is one. Oh, what about birds? So birds were alive during this time. They evolved from small carnivorous dinosaurs like Velociraptor, and their fossils are very rare during the age of dinosaurs, but we do find some of their bones in southern Utah. So we have early birds living alongside these creatures as well, and hope to find more complete remains soon. So thank you so much for inviting me to have